Thank you so much again for the opportunity to be with you all today. I would have loved to join you all, physically in person, but we thank God for the technology now that allows us to connect even in spite of our distances. So the main agenda for today is just we're going to talk about the technology core behind Autodesk solutions that help your business and your projects also achieve sustainable outcomes. So I have a couple of disclaimers here, and I also have a safe harbor statement, of course, standard. There's some data, obviously might show some futuristic technologies, but don't make any purchasing decisions. Just as a word of caution, don't make purchasing decision based on some of these statements. Make sure that you just check in with us. So diving into today's agenda, we are going to delve into sustainability as a practice, what's actually happening in the industry. The elephant in the room is defining what embodied carbon versus operational carbon, and defining the Autodesk technology landscape. And then we're going to dive deep into the technical workflows of how different Autodesk tools within covering the AEC and architecture, engineering, construction, and operations help mitigate some of that embodied and operational carbon management. And then at the end of it, we are going to do some Q&A and next steps. It is quite obvious that Africa's growing middle class is growing. And this means that there is a demand for technology, and there's also the demand for food. And so I was actually reading a report by the African Development Bank, I think, which was about 2-3 years ago, that the number of middle-class Africans has tripled over the last 30 years to about 313 million, to more than 34% of the continent's population. And it's actually bound to increase, and we are leading the globe in in terms of rapid population, and which is a good thing. But then, it's imperative to know that, and it's obvious that the more we are becoming, the less the access to the resources that we so require to meet the needs of the growing population. Obviously, we are moving a lot more towards the reclaiming land reclamation in the ocean. As you can see, 90% of the population, as it is from a report before that, it's projected that 90% of the population will be moving towards the coastal areas. So there's going to be a lot of land reclamation. There is obviously decrease of land, natural resources such as land, clean water. So there's a lot of pressure to now start thinking about sustainability. But what does it actually mean? What does sustainability actually mean? And sustainability means that we live within the limits of our planet, and it's core to who we are as Autodesk, that we want to help people imagine, design, and make a better world. You already know what you've seen. You've already seen this before, the Sustainable Development Goals, which serve as a blueprint to achieve better, more sustainable future for all of us. And these SDGs help us address some of the challenges that you're facing, and they are related to maybe inequality, climate degradation, poverty, and inequality, prosperity, peace, and justice. And as Autodesk, we are addressing all 17 of them, but focusing on four of them is very important in a much deeper aspect, because you're mainly focusing on 4 SDGs, which is goal number 7, I think goal number 9, goal number 11, and then also goal number 12, 7, 9, 10, 7, 9, 12, 11, and 12. So we will definitely need, globally, 1,000 buildings per day from now until 2050. And it's a very big opportunity for you as an architect, as an urban planner, as an engineer, to make that positive impact. But the higher the demand there is a lot of more that we need to construct and produce better. Because now 30% of the global waste coming from building industries is quite obvious, and we really need to rethink the way we are making things. And when you're looking at the wider concept of the industry, is that there is increasing project scope and complexity, as Oboho has mentioned, that many economic policies and market factors. For example, a real estate developer who's very keen on attracting eco-conscious tenants. The market as it is now is demanding a lot better buildings that not only just energy efficient, but also have a lower carbon footprint. And with economic policies that are increasing, there is that need for the developer to become a lot more competitive and adopting, better technologies. And it allows really for that precise simulation and modeling. And as developers, with the confidence of the market and the properties becoming truly green, and it's really helping them to align to some of those market trends and also regulatory environments. And of course, environmental constraint and sustainability goals, this becomes a lot more relevant in our world today. But when you're tasked with your building, with designing a sustainable low carbon skyscraper, this challenge becomes a lot more daunting. And that's where we believe that carbon management seems like navigating through a labyrinth. And the truth is that a lot of our tools right now are in a much better position to guide you. And the significant challenge of reducing operational carbon, where you need to balance technical and functional requirements with compliance and market expectations, become a turning point with the introduction of some of these solutions which are going to present to you today. And it really helps to transform how you work as an architect or as an engineer or a contractor approaching some of these challenges, so that you can become a lot more effective and manageable. So let's talk about embodied and operational carbon. So embodied carbon really refers to the total greenhouse emissions that is generated during the life cycle of a building or a product or an asset. So this includes emissions from the extraction of the materials, manufacturing, transportation, installation, maintenance, and finally going into the disposal of that specific material of a product. So we think of it as the hidden ghost of greenhouse gas emissions. So when you're talking about, embodied, so in thinking about this, the greenhouse, and it lacks in every building's life cycle, from how you're extracting, manufacturing, process, transportation, and every step you make, you leave a clear carbon footprint. And it's becoming our mission to help us understand and how we can minimize some of these steps. So we can also go into operational carbon. And operational carbon really is the emissions, whether you are, heating a building, cooling, lighting, and it becomes proactive, that we need to now adopt operational carbon management solutions or workflow solutions that helps you create digital analysis and simulations that can actually help you to reduce some of those emissions and in making sure that your project meets some of these sustainability outcomes. So when you're defining operational energy and its importance, you can see the example of a residential building. I was last in Accra in March, when it was at the peak of its, at that certain point where I really felt it was, it's a city where you really need to be, working functional systems that have HVAC for cooling as well. So defining this importance of operational energy becomes a lot more graphical when we embrace effective management of the devices that lead to substantial cost savings and reduced environmental impact on all of these areas. So when you're talking about for example, as an architect, when you are predicting design impacts earlier on, as an MEP engineer, optimizing system efficiency, or you're a contractor, you want to adhere to the specific designs of the architects and the MEP engineers, or even as an owner, you can operate the building as is designed by the architects and the engineers. And you can see even in the first paragraph where we're seeing potential, trade-off impact on the energy required for heating or even cooling a typical office building. And you can see increasing or reducing the window wall ratio, the glazing percentages, providing a lot more natural light, trading off the energy usage when compared to that of a HVAC system, especially when you are designing a modern day low energy LED lighting. So you can see how the HVAC energy can get impacted by improving the material performance, as an example, or even increasing, natural lighting. So designing becomes important to compare some of those trade-offs and seeing where you can optimally balance between performance and sustainability. But you know what? The good news about this is that 68% of the emissions in a typical building today, they can be predicted and they can be optimized using the tools, the BIM tools and analysis software that you have in the market. And for the variable emissions, we can see some offsets through the inclusion of on-site energy production like solar, wind, designing energy plus low energy buildings, and BIM and analysis software really provides that means to assess this potential. And you see the magic wand, as you can see, as you already see here, we can reduce, if you can have a magic wand that can reduce the carbon emissions by tweaking of a material that we use. For example, for engineers and contractors, optimizing concrete mixes, we achieve 14 to 33% reduction in emissions. Recycled rebar also chops off another 4 to 10%. So a lot of these reductions often come with very little or low cost. But if we actually do this in a way to assess and optimize, this really helps us reduce the costs of production and construction, optimizing how we are building and operating our assets as well. So when you're talking about assessing embodied carbon, I really want us to highlight on some of these components of when you're assessing embodied carbon, what could be some of the goals, or in what would be some of the goals that you can have. And you can see with the embodied carbon, there are some of the outcomes. For example, optioneering designs, optimizing, where maybe you want to do some material selection, meeting regulatory compliance and standards, as an example. So there are some of those outcomes that probably we need to we address when we start thinking about assessing operational carbon. And then also when it comes to that was embodied carbon. With operational carbon, you can see that there are some of these things are quite similar. Like sharing a project example, focusing on sustainable materials, things like regulatory compliance, offsetting mitigation strategies. But the good thing about this is that there's a convergence of all these components, and there's a lot of this convergence of these outcomes really helps us to really identify why we really need to encompass embodied carbon and operational carbon in our practice. The truth of the matter is that all this can be achieved by embracing 3D or model-based energy analysis and optimization solutions that helps you better understand some of these trade-offs. And for us to actually do this is that we really need to embrace BIM. And embracing a model-based design or building information modeling, it's really allowing your teams to combine some of these technologies to unlock very important insights from all corners of the different ecosystems, and also helping you to converge on the solutions to the challenges that you're facing. Because solving this really requires you to have a digital first mindset and a unified and interoperable platform. And that's where we as Autodesk, we believe that our leadership in BIM and global research, we are in a much better position to help your firm to actually get there. So before we go on, I want to ask you, is your business ready to capture some of these benefits and helping you to in helping you mitigate the risks of embodied carbon? Or have you actually assessed the value of integrating some of that operational carbon decision making with your digital, whether you're in the digital design, construction, and asset management processes? That is now where we need to talk about the technology landscape. And as a technical sales specialist working at Autodesk, it's important that we define some of those technology landscape. So from a technology point of view, of course, in the AEC space, we cover buildings, building design, transportation, water, as well as construction. So transportation also includes infrastructure is part of infrastructure is also part. Transportation is part of it. And on the right hand side of my deck, you'll see that there's a lot of the tools that we use. Some of them are proprietary Autodesk software. Some of them are third party integrations, and you can see some of the capabilities that we actually have to offer. And we're going to spend the better part of this presentation today going through some of those processes where you can use some of these tools to achieve some of these outcomes. And we can see that how Autodesk and third-party applications complement each other at each of these main project stages, like pre-designing, concepts and schematic design development, pre-construction, this is virtual design, and also going into construction and commissioning, and then finally at the handover phase and occupancy space, you can see how different tools actually cover for that. And that also goes the same for the infrastructure portfolio. So just for just as a technology landscape, you can see that we also have some access to APIs that provide that standard interfaces that allows even developers to connect your applications to multiple sustainability data sets. And they're very much regionalized from any application that needs to be deployed in multiple regions. And they often need to connect to multiple such data sets. And we have some of those sustainability data APIs that help you to reduce the overhead, scaling your applications as an example, and even connecting your users to the data that you need to use. So, okay. So I am going to jump on to, the first stages, typically going into the, embodied and operational carbon, because I have actually designed this presentation to you today to actually cover those two areas in one. So when you're talking about pre-designing, we can look at, what are some of the possible workflows for embodied carbon, and what would be the other workflows for operational carbon, what kind of Autodesk tools actually help you to do that. And then now this will actually cover the entire process of a construction project, from pre-design, concept, design development, pre-construction, construction and commissioning, as well as going over into handover and occupancy. And I hope that my time at the end of this presentation, you're going to see quite a lot of stuff. So we can start with the pre-design. So at the pre-design stage, you are an architect or an owner. You probably need to evaluate renovation or maybe new construction. You probably will need to evaluate site conditions and optimizing the location of structural foundation. And at the same time, because it's sustainability, how you can achieve carbon goals. Now, at the embodied carbon stage, it's important that during the pre-designing phase, it's very vital to set up that foundation for sustainable building projects. And that's where early evaluation allows different stakeholders to establish environmental impacts as the baseline and help you to achieve some of those goals. And you can see with Autodesk, so one of the examples that I will share with you today is how Autodesk Forma helps us to consider various physical design options and material choices upfront. So you're not just doing something for the purposes of aesthetics, you are applying sustainability in mind, making you take those informed decisions that significantly help you to reduce some of those carbon emissions from the outset. And you can compare different design alternatives, as you can see on the interface there with Forma, that enables you to identify certain layouts or structures that are inherently low carbon and still meet some of those project requirements. And you can also within this space evaluate certain material choices, like selection of sustainable materials, and this really helps you to avoid some of those costly redesigns and redesigns and rework. So at the operational carbon management, so once the design is complete, so you want to be able to assess heat gain on site, or you want to assess on-site renewable energy generation potential like solar panels, or if you want to also validate energy generation potential against predicted energy use and risks. So I'll show you an example here where with Forma, at the concept stage, an architect or an urban planner can now be able to analyze solar energy falling on a building. So effectively, that needs to go into factors of how much heat gain are we going to get, what is the increase of temperature within that building due to direct sunlight and radiation, how does this actually impact the building's thermal comfort, energy efficiency, or even cooling load requirements. So in terms of the building design, as an architect or as an engineer, you need to consider some of those factors like the window to wall ratio, shading devices, insulation. That really help you to manage some of those heat gains a lot more efficiently. And proper design really helps to reduce that need to have those artificial cooling. And you can see within in Revit, you can even at the concept stage enhance, indoor comfort and overall improve some of that energy efficiency at the pre-design stage. So we can actually go into the stage 2 of a construction process, where we now start doing some concepts or schematics design to perform whether you want to optimize systems, identifying materials for carbon reduction, or if you also want to evaluate and optimize site grading. And it's important to do that. So at the embodied carbon, if you want to now see what's the embodied carbon, carbon emissions at the conceptual stage, you will see how at the onset from using Revit, once these designs have been exchanged directly from Forma and one click into Revit, an architect can now start beginning the process of further iterating that design, that you can see how optimization of the conceptual building and further iterations with the conceptual model that can now use it to now start beginning the process of further performing some detailed energy analysis as well. Now from this side on here, you can choose the amount, what kind of material that you want to use, and then now once you choose it, you can still do the upload, one-click upload to Autodesk Insight. And then now from that stage, further iteration now helps you to see graphs of what is the total carbon, operational carbon, what can we actually do here as far as optimizing this design is concerned to help us meet some of these requirements of the project. And so this really helps you to, for example, one of the other areas that Revit can also allow for you to do as architects is being able to optimizing the site by being able to calculate the the cut and fill volume. So how much soil am I going to extract? How much do I need to fill that one in? And optimizing that cut and fills over specific site also makes it important for you to also determine what is the best optimal way of actually coming to grading that site as an example. And we've done quite a lot of there's a lot of enhancements with the latest Revit with the site design capabilities that help you to do that. One of the example here I'll show you here is that from an engineer's point of view, using tools such as Autodesk InfraWorks to come up with a concept of a roadway design project. And you see, with some of these projects, using traditional tools, you have to really do a lot of details at the design stage to come up with, for example, cut and fill reports. Corridor optimization reports as an example, or what would be the road linear costs per kilometer. And now with the InfraWorks, you can be able to do this quite more effectively at the concept stage. So that ensures that if there are any materials that need to be brought on site, what is the number of what is the total volume total volume of soil that needs to be extracted or needs to be added. And that really helps you to meet some of those sustainability initiatives, because you can also use Autodesk InfraWorks to optimize that corridor, helping you to make sure that you are meeting certain benchmarks of that project as far as sustainability is concerned. That's now for the infrastructure side. Now, for the concept stage, you will see that again, with validation tool for Autodesk Docs, we have a very important tool here that kind of like runs a health check of your BIM model, ensuring that all the properties, all the element properties have correctly been added and the classifications have been done correctly. So you can see that it's a very important tool that allows for you to do that. You can run background validation of your Revit models with the AVT tool. At the same time, even perform energy analysis at the detailed design stage. So you can still be able to further do a lot of iterations of your design even after the detailed design, even at the detailed design stage, ensuring that even with Revit, a project that has already been completed and interaction with the integration with the next gen Autodesk Insight, you can still be able to pull up a lot of these reports about total carbon, embodied carbon as well. There is also other opportunity area where you can also assess operational carbon with systems analysis in Revit, which is also a very important, a very new tool that's functionality within Revit that allows for you to now analyze different system zones that can now allow for you as a mechanical engineer to know what kind of system that you probably need to adopt for that specific system, and at the same time providing a lot more interactiveness between detailed and also construction. Further iterations really helps you to optimize that HVAC design, so that you can know what loads, what are the total HVAC loads, the sizing as well. So you know how much energy you need what kind of system do you actually require, what is the rating. So you actually know what kind of machinery you need what kind of equipment you really need to order. So when you're going to the design development, and this is now where, well, we need to look into evaluating some of those trade-offs and making critical design decisions at the development of the design, ensuring that what we have specified in that project meets that, lower carbon, and also making sure that you are meeting certain specifications and output carbons of the report. So this is now where with assessing embodied carbon at the design development stage becomes very critical for creating sustainable and even efficient buildings. So in this example here, you can see that with Revit, being able to evaluate and minimize that environmental impact of your design very early in the process. So you can, using Revit, compare different physical design options. Some of those material choices becomes important, and you can analyze different design alternatives, and you can identify what would be the best configuration that would really help you to meet some of those, mitigate some of those carbon emissions. And this dual comparison in Revit really helps you to make better decisions, not just for environmental impact. You can also make better costs and feasibility decision based processes. And this is where you can now start evaluating those embodied carbon, assess some of those embodied carbon to help you to, and your clients also reduce costly changes that potentially occur later on in the project. Okay. So when you're going into the operational carbon management, this is where this is really interesting, because at the onset, you can even start analyzing existing cities using Forma. So you have your city model inside of Forma. You can now start analyzing for lighting. You can do wind analysis, wind analysis, solar radiation, so that knows you actually know, what are the potential areas that are going to receive a lot of sunlight at what areas, at what times of the year. So that really helps you to choose what kind of equipment that you need to do. Also optimizing your windows and wall ratios. And Revit does this a lot more seamlessly now with the integration with the Autodesk Next Gen Insight. So you can see those thematic maps that mechanical engineers and even architects can generate from that. So that really helps you to know, okay, now what kind of what are some of these decisions that we need to make so that we can make sure that our building actually meets specific design requirements. This is now where it even gets interesting. Mechanical engineers, after all that is done, at the design development stage, mechanical engineers need to perform sizing of the systems, and even being able to perform computational fluid dynamics or specialized analytics for specific systems, very complicated systems. So you can know your air changes power or even the airflow direction. And that is now where you have, Autodesk, with Revit, this now with the energy optimization with the one click of a button, you can now generate an energy analytical model and define these different systems. And then further iterations takes this into with Next Gen Insight, you have a much better calculation tool that allows for you to now analyze some of these spaces and the system zones. So we have a much more revamped system analysis tool within Revit that does so. One of the other things that you can now potentially do with one of our tools, which is Autodesk CFD, computational fluid dynamics, is that you can now have simulations and understand how air or even how air moves within specific zones. Now, this is a specialized software that is specific for computational fluid dynamics. It's not just limited to building systems, but does quite a lot of advanced analytics functionalities, and we see quite a lot of this application in the design and the construction of data centers, hospitals, surgical rooms. And this really is a very important tool that can now actually use Autodesk CFD to understand how air flows in different configurations. So you can actually define some of these boundary conditions and then produce detailed reports and simulations on how, and understanding how air as a fluid actually moves, in different scenarios. So this really helps you to design better, HVAC systems, because you now have a better understanding of how air actually moves with inside the system. Now we move from design development. You now go into the pre-construction. Pre-construction means that we need to look at specific, benchmarks against specifications. So once the design is complete, we need to check some of those specifications, integrating a lot of those targets into the construction management process, and also being able to evaluate cost and production, evaluating costs versus the carbon at the procurement phase. And this is where the different audiences, as you can see, how they can actually take part in that. So again, it's important at that stage, because balancing your costs versus the carbon at the pre-construction stage becomes very critical. Because with ACC, you can identify low carbon alternatives during the design phase that can actually help you to reduce overall project cost. So if your projects that actually meet certain regulatory standards for carbon emissions really helps you to avoid some of those potential fines and delays and redesigns. So you can have a much better project progression. And also some of those projects that balance low costs, carbon, can actually benefit from increased market competitiveness. And it's important that you invest in sustainable materials and your practice upfront, so that you can lead to long-term savings through lower costs or operational cost of carbon, helping you to improve your energy efficiency and also potentially achieve some of those tax incentives. And it's important that you can see some of these tools with the with the Autodesk construction cost helps you to balance some of that carbon and cost at the pre-construction stage, so you can have a much better sustainable, cost effective, and a much better compliant approach to how you're designing your building project. So when we move over into the construction, that's where we now look at certain outcomes like managing project specifications, procurement, asset management, that is assets that are relevant to operational carbon management, and even going into the quality and even installation management. So I'll show you an example here. So what actually happens here is that with Autodesk Construction Cloud is that we can set up specifications, and we have a very nice AI-based tools that allows for us to generate project specifications. And you can set up some of those assets that are relevant to operational carbon management. And that also goes into the, long-term into the quality and installation management. As you can see here, it actually scans and automatically generates, specifications, a specification document, extracting product data as an example. So that really makes even people in a project being able to sift through certain specifications in a document, and that really helps the entire document management, specification management become a lot more effective, because you can, as specification change, all this information is actually set up correctly in your construction project. Okay, and I can also go into another example, which is the fact that you can now create request for information and attaching certain RFIs to a specific asset in that project, and specifying those assets and assigning those assets to a specific RFI. That really sets these ones up in a construction project, that you can actually track specific assets at the construction phase. Now we can also go into the other phase of construction, which is the construction and commissioning, where certain embodied carbon management practices can help you to track and record your materials and some of those as-built carbon data. Now, at the construction phase, of course, contractors being able to create safety or inspection checklists, assigning those checklists to specific individuals. Some of those issues as creating issues with and creating certain references as issues, and then being able to track a specific specific assets as far as the construction is concerned, and then exporting those reports to exporting those reports for further documentation. And so this really helps for you to track certain assets and making sure that what is being produced as built has the right information as far as embodied carbon is concerned, helping you to track on-site waste and also fuel usage. Then now we can go to the commissioning phase where operational carbon comes into place. And that's where we making sure that once the handover is completed using Revit, we have certain tools within Revit, such as the Kobe extension, that ensures that all the assets is specified as per the client information, asset information requirements is concerned. So you have certain parameters that can be set up in the Kobe extension for Revit. And then once this one is complete, you can now generate certain reports in form of a spreadsheet that you can further post-process using inside of Excel. And so you can now sift through the data in an Excel format that presents all these building information models and make the right changes as is required, so that you can make sure that all these assets information is as per the client specification. And so from that, you can now start defining certain construction assets of your building information model, and assigning some of these forms, ensuring that at that stage that when you're going into the handover process, you're ensuring that what has been specified in the document is what is specified on site. So anything that is not as per the specifications you can now flag it, and ensuring that your project is up to date and it's compliant. Okay, and all this process is actually done electronically. So when you're going into the handover and occupancy, this is the part where we talk about environmental product declarations, which are pretty much standardized documents that help you to provide what would be that detailed information about environmental impacts of your products. So in this video, you can see in tandem, it's the integration of the EPDs within a digital twin. So a manufacturer's EPD can be downloaded and they can be associated with the respective elements. And this is where we support embodied carbon management by enabling that detailed, transparent, and that dynamic approach to how we evaluating and reducing the carbon footprint of a building or even infrastructure throughout the life cycle. And you will see that at the end of the video, you will see that the main structural elements that are being colorized, that based on specific material type, together with the environmental product declaration. So you can see this the provision of the digital twin with significant support for buildings as material banks and material passports. Okay, so you can resource your you can perform with digital twin, you can track materials, you can monitor the life cycle of a material, and with a digital twin you can store and manage these material passports, which are very much a detailed record of the material properties, the origin, and the potential for users. And also, if you think about it, it also helps you to trace every material and a component in a building, so that you can track and you can trace it throughout the entire documents or the building's life cycle. Okay. And then finally, we can now go into the handover phase where checking these designs in a Revit design model. Okay, so at the handover and occupancy, as I may have mentioned here, you can check the asset, the building information data in Revit using a COBie extension for Revit, and ensuring that all this asset information is as per your client requirements, your clients or your project's requirements. And with this information, you can upload this information to, to Autodesk Tandem. And within Tandem, you can ingest that Revit model, and having that central repository of how how once the asset has been handed over for the purposes of operations and maintenance. And so with the Tandem, now this extends the possibilities of a digital twin, because you can now integrate IoT devices, and this really helps you to track real-time data of how the different systems and different spaces are performing with inside of your facility. Now, the beauty about Tandem is that this data becomes real time, and so you can also monitor the building performance. You can monitor the system's performance. So the whole aspect about a reactive approach towards building maintenance becomes a thing of the past, because now with Tandem, you can now start thinking about a reactive approach towards how you're managing your buildings and how you're managing your facilities, by having that capability to have that real-time information about how you're managing your buildings and your assets. So at the long term, operational carbon management becomes something that is fairly easy, long term, by adopting a digital twin, because now you'll have a much better view of how the different spaces and systems are performing by adopting a digital twin. And that's where Autodesk Tandem really comes into place. So as I finish off my presentation, I want you to really think about the following things, and that one of the biggest takeaways is that 68% of the carbon emissions in a building can be predicted with the software that we have in the market today, and a lot of which we've started those conversations within this webinar. And it's important to also highlight that every project has very unique requirements, and without that unified approach, it's imperative that delays are going to happen and cost overruns. So without that unified approach, we'll be prone to a lot of missteps. And the whole message about this presentation today is embracing a digital first approach. So a digital first approach means that we're embracing digital transformation, and digital transformation in the architecture, engineering, construction industry, as far as sustainability is concerned, is embracing building information modeling, or what you know as BIM, so that you can now start having that a better approach towards how we are analyzing energy, optimizing energy, so that as an architect or as an engineer or as a contractor, you can better understand different trade-offs in reducing embodied and operational carbon, further enhancing meeting sustainability goals. And BIM solutions, our BIM solutions really help you to do that, whether you want to reduce operational and embodied carbon, meeting and existing different design requirements. And it's important that I highlight that our software really helps you to meet the solutions that we have to offer, really provide our customers the need to providing healthy environments and enhancing occupants' well-being and productivity. And that's the core of our DNA. So with that, I will end my presentation.